All right, we're back, baby. Welcome to Calculus with Thomas, Part 2, Electric Boogaloo. Not really, it's because Thomas does not want to take a final. So today we're going to be looking at two problems taken from the 2018 AP Calculus AB free response. First one we're going to be looking at is the first question of the entire free response. It's a real good one. So the stimulus question is that people enter a line for an escalator at a rate mile below the function r given by that whole mess, where RT is measured by the people per second and T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second, which is fun. 0.7 person per second is kind of strange grammatically, but whatever. There are 20 people in line, time T equals 0. And the first question, how many people enter the line for the escalator during the time interval of 0 to 300? And so basically what we're going to look for there is just how many people get on. That's a very simple integral. So what we're going to do is just set up that integral from 0 to 300 using that equation. And then we're just going to get that 270 people will get on the escalator over this period of time. Next question. Bit more complicated. All these questions essentially build on each other using the same principles, by the way. But B, we're looking at during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time T equals 300? And now immediately you'll think, wait, but I already found that this plus the number of people that get in line, the 20 people that get in line, that is not going to be the answer. But then you remember, wait, people are getting out at a constant rate of 0.7 person per second. Really, that should be people, and that's bugging me a lot more than it should. The AP just disappointed me with that, I'm going to be perfectly honest. So, what you do is you set up your equation. Really, this is a formality. You could just change this to 270, but I decided to keep it, partially because I'm a little sentimental at this point. It's the end of the year. But kept that, and then you add your 20 people that you start with in line, and then minus 300 by 0.7 because you have 300 seconds and 0.7 people per second, so essentially you have a slope here, but that's separate. There's a linear relation. And so all of that, you get 80 people will be in line for the escalator at time equals 300. And then we get to, for T equals greater than 300, was the first time that there are no people in line for the escalator. And something important to note about this is that at T is greater than 300, there are no more people getting on the escalator. It is completely stopped. So now it is just a downward trend. And as we've established this linear relationship of 0.7 person per second, people per second, getting off the escalator is, okay, it's a linear relationship. This is just the slope. And so in a problem, the mx plus b, this would be m, x would be t, and the b would be whatever value we have left over from part B, because it's the number of people in the line or on the escalator at this time. So we got 80 people. That's your starting value. You're going to essentially set up the relationship y equals 0.7x. Okay, negative 0.7x plus 80. I decided to just do 80 minus 0.7x because I don't really like having negatives in front. It's a thing I don't do. And then you can just find the x-intercept, or you can move this over so you get 0.7x equals 80. Then you divide 80 by 0.7 and you get 114.286. So that's the time from 300, so you have to add 300 to that, and you get 414.286 is the first time that there will be no people in the line for the escalator. See, look, it's people here, but it's person there. I don't get it. I don't get it. I'm just a little, it flummoxes me a little bit. They write the English test too, so, But we're moving on to part D. From 0 to 300, what is the time the number of people in line is at a minimum? To the nearest whole number, find the number of people in the line at this time, justify your answer. So what this immediately screams to me is, I need to do variables. What is that actually called? I forget what it's called, but you create a table where you put on the start point, the end point, and any relative maxima or minimum. And so in order to find, here's like, you got your start point, your end point, 0 and 300. You know that there are 20 people in line at 0, and there are 80 people. Ooh, there are spoilers all over this card. Luckily, you're good at calculus. And then you know that the number of people at the end is 80, and so you have to find that value kind of in between. What is the relative maxima value? And you do that by finding r prime of t, and wherever that crosses over from either positive to negative or negative to positive, that is your relative extrema. That is the word I'm looking for. And that will be the other value you plug in. If it happens multiple times and you have multiple extrema, then you just use those. But I only found one, and it was at t equals 90. And so I plugged t equals 90 into the equation, into the integral of f0 to 90, r of t dt plus 20 minus the people out. Wait, did I do the minus the people out? Let's see. Did I? I think I did. 3.7 times 90. So, hold on. Thomas is doing a little bit of calculus. Actually, yeah, no. I don't think I did. Or if I did. But if I didn't, it's still going to be less than 20. The 20 that will ultimately come out of this. Let's see, did I do that? Okay, well, if I did, it's 63 minus. And that's still less than, well, that's still a lot more than 20. So 20 would still be the absolute minimum from 0 to 300 because it is the lowest that would be the lowest number ever to go in. I'm sorry if I'm a total mess right now, but I think that's the correct answer. And if it's not, well, that's a shame. But moving on, our second question is just the second question because I'm a lot better at the calculator portion. That's actually a lie. I just chose this because it was the first and second one I saw, and I didn't really want to scroll through to get more options. And the second question has a stimulus. A particle moves along the x-axis of the velocity given as v of t equals t sine. Okay, it's just that. For 0 to t, this is somewhere between 0 and 3.5. The particle is a position x equals -5 and t equals 0. So A, we have to find the acceleration of the particle at t equals 3, and acceleration is just the rate of change of velocity. You think, well, I say rate of change, or slope. You think derivative. And so you do that. You just take the derivative of v, so you take v prime of 3, and what you do is you plug it in, and you get negative 2.118 is going to be your acceleration of the particle at t equals 3. And now you find the position of the particle at t equals 3 for B, and that's basically part A's sister. In a way, it's a similar thing, but it's just a little bit different. And this time what you do is you just find the integral, because position is the integral of velocity. And you make sure to include your -5 because that's a starting position. So you get the integral of 0 to 3 v of t d of t minus 5, and what you get from there is negative 1.760 is going to be the position of the particle at t equals 3. C is a different concept. You're evaluating the integral from 0 to 3.5 v of t and 0.35 absolute value v of t, and you're interpreting the meaning of the context of that problem. And so what you're going to find ultimately is that the integral of 0 to 3.5 is less than the integral of 0.35 absolute value v of t. And that is because this represents it represents the position of a particle. So where it ends up after it has potentially gone above or below the x-axis several times, whereas this represents the total distance traveled in either direction. So because absolute values negate negatives, that was not intentional, but it works. Negate negatives, they will be larger if it goes below the x-axis than the non-absolute value form. So basically, that's what you get. This value is less than that value. And I don't know why I got very Texan when I said that, but I did. So basically, the integral of 0 to 3.5 absolute value v of t dt is larger because it accounts for the total distance and doesn't subtract negative area. basically an unfancy way of saying what I said earlier. And so 2D, you get is a second particle moves along the x-axis in a positive. Okay, one second. With a position given by x of 2, t equals t squared minus t from 0 to 3.5. At what time t do the two particles moving? Are the two particles moving at the same velocity? So for this one, just remember that just as the integral of velocity is position, the derivative of position is velocity. So what you need to do is just take the derivative of this, graph it, and find where it intersects velocity, because whenever they share whenever v of t and x2 prime of t are equal, that means that they will be going at the same velocity. And so you just do that. The easy derivative of x2 of t is 2t minus 1, and you just set that equal to each other. The easiest way to do this is in a calculator. Just find the graph them and find the intersect points from 0 to 3.5. I actually was, funnily enough, not able to do this on the actual free response because my calculator kept glitching and would only graph one at a time, so I had to guess. And I'm actually pretty happy because I remember guessing something 1.6, and that's kind of close to what it actually is. It's time 1.571 is where they overlap, where they have that intersection point, and I was able to find that effectively through Desmos. And that's the end of my talk, and that's the end of the two problems. But, and really, in all respects, this is the end of the year. And because, Mr. DRM, you're probably the only person who will watch this, I just wanted to say thank you for this class, and for helping me learn more about myself throughout the course of the year. I realized that I have there's a lot about me I didn't really know before I took this class, and I'm glad I know now, specifically regarding how I react to material that is just completely ungodly, incomprehensible to me. On first glance, second glance, third glance, and I have to struggle through multiple glances and multiple attempts to come close to it. No math course has ever challenged me quite like this one has. And even though I was not at times your greatest student, I want you to know that I'm extremely appreciative for the effort and enthusiasm you showed throughout the year. And I want you to know that your class has had a great impact on my life, has helped me learn about myself, and is actually probably the most educational class I took this year, in terms of just exposing me to new realities and experiences that I would have otherwise not been exposed to. And so for that, I say thank you, enjoy your summer, and goodbye.